Hello everyone. In this session, we are going to discuss the basics of blockchain components like blocks, wallets and addresses. So, what is a block? Blockchain is a chain of data blocks. Each individual block can be visualized as a page in the ledger. A block is composed of two components, the head of the block called a block header, and a body called block body. You will recall from the previous sections that the block header is divided into 6 components: the version number of the block, previous block hash, Merkle tree root hash, n bits, nonce and timestamp. Version number of the block signifies the blockchain protocol incorporated in the block. Then there is the Merkle tree root hash. Transactions are arranged as a Merkle tree to encode them securely and efficiently. Each transaction in the block is hashed and stored in a tree-like structure such that each hash is linked to its parent. The transactions' hashes are stored at leaf level of this tree. The two adjacent nodes are merged and hashed together. The hashes are merged and hashed again sequentially at each level of the tree. Finally, all the transactions are merged into a single hash at the root of the tree and is called the Merkle tree root hash. This root represents all the transactions in a relatively short string. A Merkle tree is used in place of sequentially storing transactions as it allows a quick verification of blockchain transactions. It also allows quickly moving large data from one node to another. Next is the hash of the previous block in the blockchain. This component makes a block connected to the previous blocks on the chain, having them all build on top of each other. This brings the connection and chronology between each block. Next component is the n bits. It is an encoding of the block target. For a block, a target is the threshold hash value determining the block validity. A block will be valid only if the hash of its header is below the target value. Then there is nonce stored in the block header. It is a variable decided by the miner creating the block. In order to keep the block hash under target value, the miner guesses the nonce value. This is the work a miner has to do to produce a valid block. The process is called proof of work. Block header also has a timestamp value. The value of timestamp makes the block different as compared to any other block with the same set of transactions, resulting in a different block hash. This makes the blockchain resilient to any tampering by any miner in a malicious way. Each block timestamp should follow the median passtime rule. According to this, a valid timestamp of a block is the one which is higher than the median of the preceding 11 blocks. Additionally, it must be smaller than the network adjusted time. Network adjusted time aims to keep the nodes well synchronized. It is the median of the timestamps returned by all nodes connected to your node at that time. These rules ensure that the blockchain moves forward in time, while also ensuring that the chain does not move too far forward. Building a block and adding it into the blockchain is the task of miners. Miners solve for the nonce in such a way that the new block's signature is in a particular order. Technically, the miner has to try millions or billions of times before arriving at the right number, and that is why the process is called proof of work. Solving for the nonce involves considerable computation power and effort by the miner. The whole process generates proof that the particular block has been validated and added to the blockchain. In turn, miners are rewarded for the work with coins or tokens. This reward, and the difficulty of solving for the nonce, create competition among the miners to be the first to solve it. This competition adds to the difficulty of corrupting the blockchain in any way, because every miner verifies every other miner's work. Moreover, the entire blockchain continues to function smoothly because a new block has been validated and added. In this way, as more blocks are added, blockchains can grow to lengths of hundreds of thousands or even millions of blocks, depending on the algorithm and the technology used, which determine how frequently blocks are being added. Because blockchains have become so long and because each block is linked to the one preceding it and the one following it, it becomes very difficult for hackers to modify data on blockchains. If, for example, a hacker wants to modify block number 50,000 because it would be beneficial for the hacker in some way. Also, the hacker would need to modify all the following blocks as well, and this would be almost impossibly costly and time-consuming to do. Alternatively, by solely modifying the data in block number 50,000, the hacker would in effect be creating an offshoot chain of the main blockchain, and this offshoot would be rejected by the blockchain miners and community, who always follow the longest chain. This is how blockchains are kept secure. As we have stated, each block in the blockchain is built on top of the block immediately preceding it. Thus, it is very difficult to tamper with one block without affecting the blocks it connects to. Overall, it is a very difficult task to modify any part of a blockchain without someone noticing it. An alternative option to proof of work is proof of stake, where miners develop a reputation based either upon the number of coins or tokens they own or their status in the market. The higher their reputation, the more easily they can add new blocks to the blockchain. In the previous slide, we have seen different components of a block. Now, we will see how blocks are interconnected to each other. As you can see in the diagram, there are 4 blocks numbered from 1 to 4. The first block is Genesis block, and it does not contain the previous block hash. All the blocks have different nonces and contain some data in the form of transactions. In block 1, you can see that previous block hash is absent or it is denoted by zeros. Block 1 also contains its own block hash. When you look at the second block, or block number 2, you can see that it contains the hash of block 1 as the previous block hash. It also contains its own block hash. Similarly, block 3 contains the block hash of the second block and block 4 contains the block hash of block 3. By this approach, all the blocks in blockchain are connected to all its previous blocks. Now, what are wallets? A blockchain wallet is a software that allows a user to buy or sell and store cryptocurrencies or other digital assets. Wallets also track and monitor the balance of tokens held in users' accounts. They track records of all transactions of the user for the currency from the blockchain. Blockchain wallets are technically different from the traditional pocket wallets, as they do not actually hold the cryptocurrencies or tokens. Actually, a wallet stores the private and public keys held by a user. In order to validate a transaction, the wallet monitors and reads data from the blockchain letting the user to transact a cryptocurrency. The public and private keys are a non-identical pair of a specific large length, of which, the public key is shared with users you wish to transact with and the corresponding private key is kept secret. These keys can be compared to lock and key. Only one right key can open the lock. In the same way, the key pair works only if the private key is rightly paired with its corresponding public key. Once you unlock a safe using the correct key, you get access to what's inside. In the same way, when you sign a transaction using the correct private key corresponding to the locking public key on it, you get access to that digital asset in your wallet and you can use it. Let's consider the case when a user is sending some digital currency. By doing so, the sender assigns you to be the new owner of that currency. The ownership is transferred to the address of your blockchain wallet. You can spend those coins only if the private key stored in your wallet matches the public key that the currency is transferred to. The wallet software matches the keys and increases your balance. In this process, the digital tokens are not physically exchanged, it is just that their ownership is transferred, the corresponding transaction is recorded on the blockchain, and the wallet updates the balances of previous and new owners. A user can choose from any of the 3 types of cryptocurrency wallets: software, hardware, or a paper wallet. The software wallets are accessed by downloading its application on either mobile or desktop, or it can be accessed online. Desktop wallets are downloaded as software on a computer. They are accessible only on the desktop they are set up on. These are a good option if you are not planning to access your account from anywhere other than this. These wallets are a safe choice as the keys are stored in your system. It is up to you to keep your keys secure, so make sure to safeguard your system against virus attacks. The online wallets are maintained and run on the cloud. You can access them from any device on a web browser. The private keys for these accounts are saved on the cloud, controlled by the third parties. Giving away the control of your keys always involves some risk, making them a little unsafe option to go for. Third are mobile wallets. These are available as applications on mobile and are available anytime, from anywhere. You can quickly scan QR codes to pay using mobile wallets. This is an easy and fast option to initiate fund transfer. The comfort of initiating instant payments on the click of a few buttons from your mobile phones makes these wallets most popular among all categories. After the software wallet, we have hardware wallets. These are hardware devices like USB or pen drive, which act as a wallet to store private keys of users. These wallets work with various web interfaces and they can be used to store keys for multiple cryptocurrencies. In order to use these wallets, just connect them to any internet-enabled device and provide your PIN. As the keys are not stored in a system connected to the internet, these wallets are pretty safe from many online hacks. Being offline, these are the safest wallet options available. Third, we have paper wallets. A pair of keys are generated using any software application. The private key can be saved in a piece of paper. These are the paper wallets. Now, in order to sign a transaction, the private key from the paper wallet can be entered in the software wallet. To receive any digital asset, it is transferred from the software wallet to the public address saved on the paper. And to send any currency or token, it is transferred from the address on the paper wallet to the software wallet. This is called sweeping. It involves scanning a QR code on the paper, or adding the public or private keys manually from the paper to the system. After you know what a blockchain wallet is, let us look at some of its features. First feature of a blockchain wallet is its ease of use. It is easy to use just like any other digital payment wallet that you use for your day-to-day transactions. Second feature of a blockchain wallet is that it's highly secure. It is just a matter of securing your private key, as the security of a private key can ensure the wallet's security. Third feature of blockchain wallet is that it allows instant transactions across geographies. And these are barrier-free, without any intermediaries. Fourth feature is low transaction fees. Using blockchain significantly reduces the fee for cross-border fund transfer as compared to the fee charged by the traditional banking system. Fifth feature of the blockchain wallet is that it allows transactions across multiple cryptocurrencies. This helps you do easy currency conversions. There are multiple types of wallets related to cryptocurrency, but we have differentiated all those wallets into two types, known as hot wallet and cold wallet. Hot wallets are digital while the cold wallets are physical devices. Both store the keys on the user accounts. We will try to uncover why the hot wallets are the more popular of the two. Furthermore, we will also check why cold wallets are safer than the hot ones. First, let's talk about hot wallet. Ever since Bitcoin came into existence, the digital wallets were introduced to facilitate users to execute transactions. These have been majorly online or desktop wallets. Digital wallets can hold any cryptocurrencies and that they're generally free to set up. When a new crypto token is created and is launched by an initial coin offering or airdrop, users require a place to store and support it. Generally, the crypto is launched with a wallet of its own which is compatible with it. Various better known and widespread adopted cryptocurrencies, like Bitcoin, Ethereum, XRP, Cardano and others, are supported by a wide variety of digital wallets. Other than the basic functionalities, these wallets offer different features and personalized customizations as per user. The newly launched or the lesser known cryptocurrencies have limited wallets with the basic options to buy, sell, and trade. The key difference in the hot wallets and cold wallets is the ability to hold various crypto coins. Many people who hold or want to hold different, less mainstream crypto coins, cannot use a cold wallet. Another factor is that the hot wallets are mostly free of cost. Users can simply find a hot wallet that suits your needs, register for it, and start using it, free of any charge. On the contrary, cold wallets are generally hardware devices that are costly. This has reduced the use and popularity of cold wallets significantly. Next is cold wallet. As we have discussed, the cold wallets are specifically designed hardwares that are designated for physical cryptocurrency storage. One of the biggest advantages of the cold wallets is that you can also keep them with you. These devices are usually small and compact. These are comfortable to carry around while keeping your crypto safe. But the notable drawback of cold wallets is that they are expensive. Typically they cost around a few $100. Another drawback is that cold wallets support a limited variety of cryptocurrencies to store. They mostly support main crypto coins and tokens in the market out there, such as Bitcoin, Ethereum, Dash, etc. Now, what is a blockchain address? In its initial days, Bitcoin could be sent directly to the user's IP addresses. This was to make it user-friendly and convenient for an average user to transact Bitcoins without having to deal with long public keys and addresses. However, this payment method is vulnerable to man-in-the-middle attacks, and it was soon dropped. The Bitcoin payment moved from IP addresses to cryptographically generated addresses. After paying directly to the IP address, Bitcoin adopted another payment model, called Pay-to-Public Key Hash, P2PKH format. This is the current addressing system in Bitcoin transactions. A standard pay-to-public key address has 34 alphanumeric symbols created by hashing and rehashing the public key. It begins with character 1. Every wallet supporting Bitcoin can create these addresses. The cryptographic operation behind the address generation in blockchain is as follows. Users can create their wallets using existing private keys, or the wallet software can create new private keys and associated accounts for the users. In order to create a private key, the wallet securely generates entropy, and comes up with a secure and random private key. Bitcoin uses elliptic curve cryptography to mathematically derive the corresponding public key from the private key. It is important to note here that you can derive the public key from a private key, but it is computationally infeasible to get back at the private key using its corresponding public key. This makes it safe to publicly announce your public key to send and receive crypto payments. Cryptocurrencies use the asymmetric cryptographic algorithms. In order to send transactions from the public address, transactions are signed using the private key. The transaction signature can be verified by anyone in the network, including the receiver, using the public key of the sender. Bitcoin uses Schnorr signatures along with elliptic curve digital signature algorithm to digitally sign the transactions. These signature schemes are used for proving that the user is the actual creator of a transaction by digitally signing it. To generate the user address from the public key, the wallet again uses cryptographic algorithms. It begins with hashing the public key, a cryptographic algorithm, SHA-256. The resultant hash is rehashed using another cryptographic algorithm, RIPE MD160. Subsequently, a prefix 00 is added to the resultant hash string. This makes all the paid public key hash addresses in Bitcoin to begin with the number 1. At the end of the string, 4 checksum bytes are appended. Finally, the wallet encodes this string with a base 58 encoding, and we get a Bitcoin address corresponding to the supplied public key. The resultant address is a representation of the public key. The checksum is added to remove some alphanumeric characters from the address to avoid possibility of a typing error. Bitcoin wallet calculates the checksum for each address. If it doesn't match, the address gets rejected. Now when a transaction is created, the user who holds a private key corresponding to the address is the only one who can sign a transaction generated from this address. Any user who knows the address can verify the signature upon receiving the transaction, without actually discovering the private key. That was all for this session. Thank you.